Hi everyone, today we're going to be talking about the scientific method. It's the basis of all scientific discovery in history, so it's important for us to use it in our scientific discoveries as well. The scientific method can be remembered through a short acronym, ABCTAC. A stands for ask questions, B for background research, C for construct a hypothesis, T for test with an experiment, A for analyze data, and C for communicate results. Ask questions is the first stage of the scientific method. Every single scientific discovery has begun with somebody asking a question. And we as scientists, in our everyday life, we ask questions all the time based on our observations, what we see, what we smell, what we hear, what we touch, and what we taste. When we're asking a question at the beginning of the scientific method, we need to think about whether the question can be measured. Is it measurable? Is it something that we can measure and find the answer to? The second step of the scientific method is background research. In order to find out more about our topic that we have asked a question about, we need to find whether anybody has researched this area before. So we look for prior findings. In our background research, we might also come across the best way to go about doing and carrying out the scientific method. So we might find out more about the techniques and equipment that we need to use during this process. The third step of the scientific method is construct a hypothesis. A hypothesis is an educated guess about how something works. We also need to make sure that our hypothesis can be measured. Does it address the original question? And the way to format our hypothesis so that it can be measurable and so that it does answer the original question is to remember to put it in an if-then statement. If I do this, then this will happen. Once we've constructed our hypothesis, we can move on to the fourth step of the scientific method, which is test with an experiment. This is the fun part. Our experiment tests if the hypothesis is true or false. When we're doing an experiment and testing our hypothesis, we need to make sure that we're running a fair test. A fair test is a test where one factor changes and all other factors remain the same. For example, if I'm testing something that involves dropping an object from different heights and measuring the time it takes for it to fall to the ground, then I might change the height at which I drop the object, but the weight of the object and the object itself would remain the same. Once I've conducted the experiment, it's important to repeat it so that you can get accurate results, to make sure that the results that you came up with weren't just an accident. Once we've tested with an experiment, we should have a whole range of data that we can look at and analyze. And that's the fifth step of the scientific method, to analyze the data. When we analyze the data, we determine whether our hypothesis has been proven true or false. If it's true, great. If it's false, we might need to adjust and go back a few steps, formulate a new hypothesis, and do the experiment again. The last step of the scientific method is for us to communicate the results. We need to present our findings in the form of a report, a model, perhaps a video, or some other type of publication. When we communicate our results, we really need to take into consideration our audience. Are we presenting to young people or perhaps more educated people? And we need to tailor our communication of the results to that age group and target audience.